Today we're going to be talking about sustainable construction and decarbonised energy solutions, and what I'll do first is introduce you to Janet Bailey. Janet and Paul run the National Brownfield Institute very, very well, I have to say. Janet's saved my bacon a few times, especially with this one. So without further ado, I'll hand you over to Janet. She'll give you a brief overview of the National Brownfield Institute.
Morning everyone, welcome to the National Brownfield Institute. Some of you I know and some of you are new to the facility. So as Dan said, my name's Janet Bailey. I'm a bit croaky today. Knowledge Transfer Manager for the National Brownfield Institute and the School of Architecture and Built Environment, together with my colleague Paul Davis. I want to give you an overview of our vision for the rest of the site. I kept it very simple here. So ultimately what we want to be is a super campus as a centre for sustainable construction. So I'm just going to walk you through what some of those rectangles mean there. So the School of Architecture and Built Environment, obviously a class-leading learning environment. We get some great graduates from that, architects, civil engineers, etc. We also look at traditional build versus modern methods of construction. National Centre for Circular Economy, we don't have that just yet, but that will look at recycling, remanufacture, reuse, and look at that circularity cradle to cradle, which I think we've all got to move forward more on now. We need to progress that. National Centre for Sustainable Development and Climate Change, again, not in place. We do have many of our academics that have expertise in these fields already. So that really is about reducing the impact on the environment from construction and regeneration. And looking at sort of things like biodiversity. So I'm just doing a little soft touch and giving you a flavour for what this will look like. National Construction Incubator, that will be support for new business, so to attract those new ideas, new innovations into one space and give people an opportunity to talk about and develop those ideas. National Centre for Asset Management, well, that's really about a framework to develop, monitor, measure sustainability. And National Brownfield Institute, which is where we are now. At its most basic, it's about bringing brownfield land back into economic use. So let's focus a little bit more on National Brownfield Institute. So with that view, bringing brownfield back into economic use, we want to do that by creating this brownfield hub, bringing together the multi-sector partnerships and industry leaders, SMEs, larger organisations, but it also complements that Springfield vision for the overall sustainable construction in excellence centre. And also it puts our position as a leader as the City of Wolverhampton in sustainable construction and brownfield development. I just want to tell you a little bit about our strategic approach in terms of our location. We're very close to Wolverhampton city centre, and so we're very close to some of those game-changing developments that are taking place locally at the moment. So we've got the canal side quarter, we've got Brewers Yard to be developed, and there's a lot going on locally and in the West Midlands at the moment. We've also got the DLUC, the Department for Housing and Levelling Up offices, now has a presence in Wolverhampton. So we've had a visit from Michael Gove and many of the employees there. So we're getting our presence known not just locally but nationally and in at government level. It's a great opportunity to influence those construction methods. We're easy to get to by road or rail. And as I've said, there's that strong developer and investor interest locally for us. So what does that mean for business? So as part of our funding, the university made a commitment through the National Brownfield Institute to support hundreds of SMEs with 12 hours of funded support. So that's free support at the point of delivery. That can take many forms. So here's just a few examples really. We'll go into more detail on this when we demonstrate and walk you through the tour later. The modern facilities. So as an SME with their 12-hour support, you can use this facility utilising those 12 hours, and that includes any of the spaces, multiple spaces, the igloo and the igloo lounge. Again, you'll see the igloo later. Research and innovation. We've got access to academics and industry leaders, so to help with support, research and innovation around maybe new regeneration methods, cost-reducing regeneration methods. Laboratories and testing, we've got world-class laboratories downstairs. They're still in the process of being commissioned, and we're recruiting a little bit later in the year for those technicians. The knowledge transfer opportunities, what we want to do is to help SMEs develop to demystify brownfield land development. So take that from literally what is brownfield land through touch points on the planning process, risk assessment, remediation techniques, so they understand from start to finish what that involves. State-of-the-art equipment, I'm not going to go into detail on that because we'll talk about that shortly, but that's more around surveying and what we can do on-site investigations. And the business support is targeted, focused. We need to have an individual conversation with an organisation, then we can get a feel for what they need to maximise that free 12-hour support. These are just a few shots of what we're going to show you. So we've got the Igloo 360 immersive space. I'm not going to say more than that because you really need to see that. We've also got a 270 immersive room, which you can have a wander around and have a look at shortly. We've got Spot, Boston Dynamics Dog. I mean, its main task really would be to go onto sites that are more dangerous than humans would initially want to access. Take a look what sort of things are on there. Of course, we have to be careful where we go with him, because if we've got to decontaminate the dog, it then presents its own problem. So, but there's still a lot that it can do. We'll talk you through some SLAM-based technology, which is the simultaneous localization and mapping technology. So we'll talk a little bit more about that later. Producing point cloud data. So these are just some real touch points that we'll go into a little bit more detail on. Contact details are on there for myself and for Paul, and I think Dan's going to send out the presentations afterwards, so you can have a conversation today with us or contact us separately.
Okay, so I'm Dan Downs, I'm from Land 360. We're a consultant that work with companies to help them achieve their growth strategies. So if they've got a new project coming up, we will go and spend time with that company, fully understand the company, have a look at the projects, their current and future projects, and look at what in-house resources they've got. We then help maximise those in-house resources and then go out to our network of contacts, which is extensive, to get the right experts in for them. Many businesses work on projects with a can-do attitude and will purely rely on in-house resources, which is commendable, but often leads to expensive and time-consuming iterations to the point that they have to go back and get the experts in when they should have done at the start. So we help bridge that gap by introducing them to those experts. We've got, like I say, an extensive network of contacts at decision maker level. So we can talk with companies that are fluid and able to make decisions there and work on quite a reactive and proactive basis. Getting the right experts in at the start of a project who have that collaborative mindset means projects are realised far quicker and with a much higher degree of success. As I say, this saves significant time and money, and one of the outcomes that Land 360 as a business help them achieve. We've worked on a range of different projects from last month's event that we did with ATG, helping unlock brownfield sites, making them more accessible so that people realise brownfield sites aren't these dirty sites that are expensive to remediate and develop. Quite the opposite now. One of the partners we work with, ATG, provide a land remediation service where they treat 70% of the contaminants on site. So that helps reduce the CO2 output because there's not much going to landfill. I've worked on a project where an engineering firm had to make 300,000 telescopic buttons for the Indonesian police force. That was quite interesting. They went with the old Richard Branson motto: if someone offers you a good opportunity, accept it, then work out how to do it after. Okay, so that's who Land 360 are. One of my favourite sayings is necessity is the mother of all invention. So essentially things get solved when there's a need to have them solved, and that's very much what today is about, that and the power of partnership. Not all inventions are groundbreaking, as you can see. One of these days, someone's going to pop up out the audience and go, "That's my dad." It hasn't happened yet, but it may do. But I think it's important to realise that, you know, at the very simple basis, this guy needed to sit and eat his tea comfortably in front of the dinner, in front of the TV. Businesses are looking for a cost-effective solution to their problems. Money's tight, so this is what we help them do by accessing that network of contacts. A lot of forward-thinking businesses are now putting sustainability plans into place. Where it was 5, 6, 7 years ago, oh yeah, that's something we'll start looking at doing. The time's now. Businesses have got to do it now. There's the ESG framework coming out. Richard Cannon and I were speaking the other day. All the grants and cheap funding that was out there for these renewable energies has slowly dried up. I was talking to one large developer. They put 15 applications in for the Green Heat Energy Network Fund grants, and every single one of them's been turned down. So I think that tells you where the government are and where we are now, that it's not all out there. So those incentives are becoming less and less. And as Richard quite acutely put it, next comes the stick. There will be penalties going forward if you're not working towards net zero. Now, it's not to say that there aren't funding solutions out there, because there are. But finding them, working out which is the right one for you, is quite complex work. This is why we've got Adam Sidat here today, Director of Signature Group. And they'll present some of the funding options that are available to businesses, whether that be asset finance route, having a review of your tax reliefs. Every pound counts in all of this. Solar now has a payback of anywhere as little as 2 to 3 years, David.
Can be.
So solar has to be taken more seriously than it ever has done. It's not just keeping up with the Joneses in the street. Look, we've got solar panels. Solar can generate all the electricity you'll ever need. So when the 2 to 3 year payback for the initial outlay, you'll then generate completely free electric, and probably more than what you need. So there are several options that you can do with that electricity. You can pay it back to the board, back to the grid, or you can look at putting EV charging points in and using that excess electricity for that. Ground source heat pumps are a fantastic source of heating and cooling, and Richard Canning, Head of Ground Source Heat Pumps for SSI Services, which are South Staffs PLC's technical division, will talk to you about that more in his presentation.
So, as has been well covered just now by Dan, collaboration is what this is all about, to make sure that providers can access the swiftest way to a great solution for everything from the land they're going to build on to switching on the lights and opening their unit, whatever it might be, whether it be a care home, hospital, school, or whatever. So I'll just introduce very quickly the ones you haven't met so far. Climateshield Solar, that's us. Climateshield Roofing is our sister company, and make sure that any building that's being retrofitted is fit for purpose, to make sure we can get the solar on the roof, and indeed we'll put roofs on new buildings if that's what you need. SSI Services, that's going to be well covered, I'm sure. Smart Power Systems is our strategic partner for batteries, battery storage, and Dr. Ian Chilvers is in the room, so questions for anybody having any interest in understanding batteries, he's over there. Land 360, Dan, none of this would have happened without Dan, and of course being here would have not happened without you, so thank you very much, Brownfields Institute. It's a real pleasure to be here again, and I hope everybody gets as much as they need from this presentation. So moving on, this is one of our sites that should start playing. There you go. So the Climateshield Solar was founded 3 years ago by Darren Pelling and Carl Jackson and Dave Scott of Climateshield Roofing, to bring our efforts to initiate as much as we could to help with climate change. The whole premise on the Climateshield Solar's vision is to be at the forefront of ensuring that only what is required is specified, rather than what a great deal of solar cowboys out there are doing, which is just saying, oh yeah, you've got a roof, we'll cover it, no worries. and isn't necessarily the best business model for them. That has been what we've been doing for the last 3 years. We've worked very closely with a number of care home groups and with some very large companies that do a lot of logistics, which we are doing some major commercial roofing installations, and also ground mounts. Ground mounts are another area that we do a great deal of. Now, none of that is of any consequence if any of that energy is being lost, and so we have battery storage is the next pillar of our offering. Specifying the right battery is absolutely vital to make sure that as much of the energy you've got is used for what you need it for, first and foremost, and then whatever's left is directed in the right way so that energy can be converted into an income stream if you're producing that much. Of course, with our offering with the ground source heat pumps, there is the fact that a lot of that energy will be used for that, which is why the battery is so important, to make sure that the ground source heat pump can then keep running on the renewable energy that you've produced with your panels thereafter. There's a couple of instances there as to what happens if you have the wrong size battery. You've got to make sure that the battery is charging and discharging in real time and based on the best financial return for the company. So it's all about the viability of the solution that Climateshield Solar will specify to make sure that the business model that you wish to adopt is achieved in the best possible way. SSI Services is up next. Richard, if I could invite you up. I was going to go through a whole load of notes, but I know how much you've got to say on your own subject.
Right, so I'm Richard Canning from SSI Services. Sorry, I've dropped a screen already. I'm head of ground source, so my whole job is to get heat pumps installed using ground source, but I'll talk to you about any sort of heat pump and also generally about renewables because it's sort of what I like doing. Topics I want to go through today, talk to you a bit about South Staffordshire PLC and SSI Services and Integrated Energy, who I work for. Drive to decarbonise, Dan's alluded to the carrot and the stick options, and I think we're going to see the stick soon, so we need to be taking this into account. About ground source heat pumps, the main components of ground source heat pumps, and I don't mean the box, I mean the bits you need to put it all together. This isn't a talk where I'm going to get into the details of how a refrigeration circuit works, and this is an overview to give you some ideas. I'm happy to talk about the details if you want to, but I will bore you to death. Ground source heat pumps, the benefits, and then I want to talk a bit about heat networks. We've spoken about care villages rather than just a care home. With a care village, a heat network might be one of the best options, so it's worth having a chat about those as well. So, South Staffordshire PLC, I don't know where that is. Does anyone recognise the picture? It's my marketing guy put it together. I have no idea where that is. It could well be. So, South Staffordshire PLC, we're owned by Argent Infrastructure, who are our main shareholders. They put the money in. Then we South Staffs PLC at the top, and then we have two regulated businesses, South Staffs Water and Cambridge Water. So they provide the water coming out of your tap if you live in that area. I think you do, don't you, Robin? You have South Staffs, or in Cambridge. So they're basically water companies. Clean water only. We don't do waste, only on the clean side. And then there's on the non-regulated side, we have SSI Services, who I work for, and an establishment called Echo. Echo are a customer care type system. They produce software and desks and that to answer customer care phones. So they're an environment on their own, and they sell software into America and places for that sort of function. SSI Services, the bit I work for, something like 1,750 employees, 23 sites over the UK, something around 160 million turnover. So not a small enterprise, a fairly reasonable sized enterprise. And it's split up into a number of companies and brands. Starting on the left-hand side, AES look after gas and water pipelines as well as vessel pressure testing, and there's a lot of work I don't understand in gas where you need heat exchangers and other stuff, and they do all of that side. GSTO are probably the oldest drilling company in the UK. They've been going since the 1800s. Were involved in drilling from the military in both world wars, and have been drilling boreholes to the water companies for eons. Hydrosave are a water infrastructure company who look after things like leakage. They have leakage detection, so they go out and try and stop some of the wastewater. They have valve release technologies, and they work a lot with the water industry. You're probably getting a frame here that a lot of us work with the water industry because that's where we come from. IWS mechanical and electrical contracting. Guess what? They fit out treatment plants and pumping stations and things for the water industry. So they built up a huge repertoire in terms of electrical installations and mechanical installations. And also a specialism in abstracting water from rivers, which for the water industry is really important. That's where a lot of our water comes from. But also for ground source, because we can take that water and take the energy out of it and utilise that energy. So it's a huge benefit to us. On-site are split up into clean and dirty, or clean and waste, I should say. I don't work for the dirty side. So pipeline in the ground. If water mains, pipe work, on-site are putting pipe in the ground every day of the week. They're doing things like replacing lead pipe work for Coventry, I think it is. So from the main into people's properties, taking out the lead that's still existing, frameworks for doing that. They work again with a lot of the water companies in putting pipe work in, but they also put pipe work in the ground for people like the Eden project. Eden have drilled a 5 kilometre borehole to take advantage of the core temperature of the earth, and are utilising that to heat the domes in the Eden. I don't know if any of you have been to the Eden project, but heating the domes. On site did the pipe work from the borehole to the energy centre, which is about 3 kilometres of pre-insulated steel pipe that's welded joints, then re-insulated. So very good at putting pipe in the ground, very clean. And then Amiga Red are a electrical company. They do electrical earthing, lightning protection, EV chargers and things like that. That's the business side. Let's move on. Integrated energy. Basically what I do is pull three of the businesses together to provide a ground source solution. GSTO do drilling, interconnecting pipe work with on-site, so from the boreholes to the manifold, from the manifold to the plant room, they do all of that pipe work. And in plant rooms, IWS are brilliant at putting in plant rooms. I wouldn't let them in my house to put a heat pump in, but I'd let them in any plant room. They are fitters, not domestic engineers, so they're good at that. We don't do domestic. But I know plenty of companies do if anyone's interested in having heat pumps put in. So that's my bit about the company and who I work for, which is the boring stuff. Now, this is the bit I really like, the drive to decarbonise. This is becoming critical. At the moment, the government is giving us money to do it. They will stop doing that and they'll come along and hit you over the head with a big stick, and they will force you down this road. We have no option, we have to go there. Whether you believe in climate change or not, you're going there at some point. And on that picture, there's a variety of different sites I've worked on. Top left is a borehole in the Black Mountains where we were putting some ground source heat pumps in. The middle one is 3 air sources that are actually heating an outside swimming pool. The one on the right is Bath Abbey. That's a drain where the water that comes off the spa goes down at high temperature, 40 degrees. High is relative. And we take the energy from that and utilise that in the plant room to heat the Bath Abbey. And then there's a couple of plant rooms. One's a large industrial size or commercial size plant room. One's slightly small, that's probably a couple 100 kilowatts. The industrial one's the one on the far left. So UK government have committed in legislation for the UK to be net zero by 2050. This line used to say that's in the next 30 years. It's only 27 years now. Time is flying by, and we need to be thinking about this on our new builds now rather than waiting for it to happen. 2035, they're looking to have a clean electricity supply, so taking out the fossil fuels and using wind and PV as the main drivers, and nuclear, which is going to play a big part as well. And I know they've put subject to security of supply. We've seen the problems with security of supply with the Ukraine issue and the Russian gas and such like, and what that's done to our energy prices. This is really important, and we need to become more secure, not less secure in this. Ambition that by 2035, no new gas boilers will be sold. That includes replacement. So by 2035, they're looking to say you can't actually replace your gas boiler if it breaks down. You're going to have to put something else in. So that's coming to us all moving forward. A bit of a caveat there. There was a hint in the press the other day that if you fit a hydrogen-ready boiler, you might be okay. I have my doubts. Delivering cheaper electricity by rebalancing the costs from electricity bills to gas bills this decade, so in the next 10 years. At the moment, electricity costs are about 34p a kilowatt hour, and gas is about 8 pence a kilowatt hour. That needs to change. And as we electrify our heating networks, and that will change, and gas will become more expensive and electricity less expensive. And that will drive the push to heat pumps, both ground source and air source. Renewables. So one of the ways of decarbonising is starting to use renewables as your source for heat. David's talked about PV, which is really important because that's free energy. The more you can generate, the freer it is. It's brilliant. But renewables, if you can then use that energy in a way that makes best advantage of it, great. So I've put up there some indications, pictures of renewable energy. So on the left-hand side, biomass. Biomass is still classed as a renewable energy, although there are question marks about particulates and filtration and other things, but it is still up there. PV, obviously, as David said. Hydrogen-ready boilers, it is definitely in the press and it's spoken about, and Jacob Rees-Mogg thinks it's a silver bullet. I personally don't, and I'm happy to have that discussion with anyone if you want. And why I don't, it has a huge place to play, don't get me wrong. I think it'd be really important in our economy going forward, but I don't think it will be used for heating in the way that the boiler manufacturers do.
I'm sure we'll hear that Rees-Mogg has got an interest in a hydrogen renewable.
No, surely not, Dan, surely not. We would not cast that dispersion, would we? I certainly would. On the left-hand side, an air source heat pump. Air source are brilliant, not as efficient as ground source. And on the right, some ground source. That's actually a job I worked on in Reigate, a school in Reigate, where we put about 1 megawatt of heat pumps in. Really nice project. Not with SSI, unfortunately. It was a previous life. Heat pump solutions have been identified as the best cost-effective solution to reduce carbon emissions. So looking at all those options, heat pumps are the best option in terms of reducing carbon. Ground and water source solutions provide the most energy in carbon efficient systems for heating. So if you look at the availables, air source, ground source are better than air source in reducing carbon and costs. And there's a reason for that, and I'll explain it if people want. And a typical ground source water source pump will have an energy efficiency of over 400%. How can anything have an efficiency of over 400%? We don't call it an efficiency, and I'll talk about COPs a bit later on. What it means is, and this will come up, but what it means is that for every kilowatt of energy you invest in a ground source heat pump, you will get 4 kilowatts of energy out of it, because the other 3 come from the ground. That's why it's got an efficiency of 400%. So talking about ground source heat pumps, that's a picture of Swaffham Prior. Anyone heard of Swaffham Prior? Village in Cambridge. Put one of the early energy centres in. So this started last year. I think it came live early this year. It's about 1.5, 2 megawatts of heat pump in the building on the left-hand side, which is the energy centre, and it's supplying a village of about 100 homes. And they've got quite a few, 300 homes. They've got about 100 of them to sign up so far. So they're delivering energy to those homes at high temperature, which is quite a good investment. It was Boygues, I think, who did all the work. It was a really nice one. The reason we've got the photograph is we did all the interconnecting pipe work with on-site. Ground source heat pump is a low carbon heating system and provides space heating, domestic hot water, and also cooling. Cooling is really important and will become more so as climate change takes effect and people want to live comfortably. But it also has a great benefit. If you can put a system in that will do both heating and cooling, the cooling load can be put back into the ground and then reused during the winter. So it makes the systems more efficient. Ground source heat pump can replace entirely or work in conjunction with your existing heating and cooling systems to provide low energy. So you can, if you've got gas boilers in there, put the ground source in, use the ground source and have the gas boilers there as backup and support. or you can just take them out, which is by far the best way. Ground source heat pump takes the heat stored in the ground at low temperature and then uses a heat pump to elevate that temperature up to what is usable. So the ground temperatures, drop a borehole into the ground about 150 metres, you'll get 10 degrees out of that all year round. And then we can use a heat pump to deliver that from 45 degrees up to 75 degrees. Heat pumps can do 75 degrees quite easily. The only thing is, those two temperatures are like this, so you've got 10 degrees here and 75 up here, and the distance they are apart shows you how efficient the system will be. So the closer you can get to them together, the more efficient the system is. So you're always trying to lower, you can't do much about this, but you're trying to lower this temperature as best you can. Heat pump efficiency. So boiler efficiency, I think you're all fairly straightforward. You put a kilowatt hour into a boiler and you get 0.9, if it's a gas boiler, a decent one, you get about 0.9 of a kilowatt hour out. So you're losing about 10%. If you look at older systems where you've got old fired gas boilers and they're not what is euphemistically called condensing, you're probably only getting 60%. So you put a kilowatt in and you get 0.6 out. So they are quite, which is why you should be upgrading your boiler at the very least to a higher efficiency boiler. Heat pump will produce between 3 and 5 kilowatts of heat output for every kilowatt of heat energy you put in. Again, that isn't free, it's coming from the ground, it's coming from solar again, from the heat that the sun is heating the ground up, we take that energy and utilise it. That's expressed as a COP, or a coefficient of performance, or an SCOP, which is a seasonal coefficient of performance. Coefficient of performance, energy out divided by working gives you the coefficient. With a seasonal, it's energy in over 12 months divided by, energy out over 12 months divided by energy in over 12 months. So it just shows you, because temperatures change, in the winter you need higher temperatures in the building, and therefore your efficiencies come down because this has moved. If you're using horizontal collectors, and I'll come on to different collectors in a minute, the temperature will drop, so this is moving. So your efficiencies change, they're not all bench tested, and thus you get this seasonal coefficient performance. It measures how the heat pump is performing over a whole 12-month period, the seasons. So heat pump system has 3 main components. And again, I'm not talking about the box for the heat pump. You have the collector to collect the energy out of the ground. You have the pipe work from the collector to the plant room to deliver that energy to the plant room. And then you have the heat pump and the plant room and the bits of kit in there. The energy collector, the same picture of the borehole. Boreholes can be what are called closed loop or open loop. Closed loop is basically a borehole about 150 mil diameter, in which you drop a U-tube of pipe down to the bottom of the borehole, and you circulate glycol or an antifreeze through that to collect the energy out of the ground, which then goes off to your heat pump to heat it. An open loop is where you drop the borehole, slightly bigger diameter, into an aquifer. You abstract the water out of the ground, you pass it through a plate heat exchanger, take the energy out of it, and then you put that water back into the ground something like 100 metres away so that it doesn't affect the aquifer. So all you're taking from that water is the energy. You're not taking anything else from it, and it's easier to just drop it back into the ground then. And then plant rooms. That's a nice plant room. And it shows the main components. It's technical, so I'm not going to go into too much detail, but on the left-hand side there's a couple of heat pumps. On the right-hand side, the tall vessel, that's what's called a thermal store. There's no domestic hot water on this, so we're just doing heating. And then there's also the flexi heat, is an electric backup boiler, it doesn't need it, but it was asked for, so it's in there. And that's actually heating a World War I hangar using some air handling units. Project that's going in at the moment. And here's a couple of plant rooms, nothing special. You'll notice the heat pumps, a lot of this particular heat pump being used, there's a reason for that, and I'll come on to it in a minute. The one on the right-hand side is Bath Abbey. One on the left-hand side is Wimpole Hall. Both of those buildings are old, drafty, uninsulated, and are heated easily with a heat pump. Wimpole Hall is a National Trust property, again, old building, it's drafty, it has no insulation, it's been heated by ground source. Don't let anyone tell you you can't heat old buildings with ground source or air source heat pumps, you can. So, benefits, reduce energy consumption. We've seen that you get 4 out for 1 in, so you've got a 70% reduction in energy. Reduce carbon emissions, 66% at the moment, but as the grid's carbon content drops, so that will increase the amount of carbon you're reducing compared to things like gas and oil. So that's improving all the time. Reduced operation and maintenance costs, they're cheaper to run, and also they're easier to maintain. Heat pumps are very simple to maintain. You don't have to do an awful lot. There's no gas checks, it's much easier you still need an annual checkup obviously, but much easier to maintain. They're a low carbon technology, they future-proof your plant. You're already up and running with a heat pump, so if you've got to replace it, you're up and running with a heat pump, it's easy to do. And you can deliver delivering client net zero commitments. Lots of people have got things on their website saying, we intend to be net zero by 2030, 2035. If you ask them how they're going to do it, they don't often have an idea, they're not sure yet, or we might put some PV up or have electric cars. So this is one of the ways they can clearly show they are decarbonising and going towards net zero. And you can demonstrate your decarbonisation credentials. So I've spoken about heat pumps and collectors, interconnecting pipework, plant rooms. What I want to talk a little bit about now is what's called heat networks. So at the moment, I've been sort of thinking of this as, well, here's a building over here, we'll put a ground source heat pump in it, drill a few boreholes to supply it. What I'm now thinking of, we've got an array of buildings over here, a care village, for instance, and we can put in a central plant or we can put in an ambient loop. So networks, heat networks, centralised plant room or an energy centre with heat distributed at relatively high temperature, not 750 degrees C, but 75 degrees C. There's a no gone wrong there. 200 properties. Each property would then have a heat interface unit. Heat interface units are boxes about this size, and inside them they've got a couple of plate heat exchangers, a couple of pumps, and you bring your pipework into them and then distribute off to your heating circuit and to your hot water. They're quite small and convenient. Existing heat works generally use gas or oil boilers or combined heat and power. Does combined heat and power, everyone knows what I mean? If you don't, what it means is you generate electricity with a turbine or gas or whatever, and you take the heat and use the heat as your heat source. So you're doing 2 things at once. You're getting twice as much for your buck, as it were. And in pipe work from the energy centre to individual properties is pre-insulated steel, generally with welded joints. If you remember I was saying about the Eden project, that was all pre-insulated steel with welded joints. It's that sort of pipe work, and it has to be insulated because you're distributing at high temperature. Networks with ground source. There's no reason why we can't do a heat network with a ground source heat pump. And the picture I showed you of Swap and Prior is exactly that. It's an energy centre with distributing heat to individual properties, and each property will have a heat interface unit to pick up that energy and utilise within the property. So we can do an energy centre with distributed heat, which we call 4G or 4th generation. Oh, it's not a term I like, but whatever. But there's also another option where we could use an ambient loop, which is what we call 5G, the 5th generation. So energy centre, a typical layout, you've got the big energy centre, you've got housing, commercial, apartments, and each one will have a run of pipework going to it, taken from the energy centre, elevate its temperature, distribute the heat around the estate, and heat interface units in each, whether it's a commercial building or whether it's a domestic building, they can have heat interface units to take the energy. Ambient loop, we take the energy out of the ground, and instead of turning that into high temperature and delivering it to the properties, we deliver that energy to the property and put a heat pump in each individual property. So if you've got an estate with a number of bungalows, a big care home, and perhaps even some commercial, we can deliver that ambient temperature to each of those developments, and they can have the appropriate ground source heat pump or water source heat pump or whatever it is fitted in that property to provide that energy. So I've spoken at length about ground source, probably too much length to be honest, and David's spoken about PV, and I think it's really important that we look at what I term, and Dan used the term as well, an holistic approach to energy. Rather than just, oh, I'll put a ground source in, that's fine. I'll put some PV on the roof, that's fine. I'll put an EV point in, that's fine. I'll put a battery in. We need to think a bit more cleverly than that now, especially on new estates when we can take advantage of linking these technologies. So I want to cover sort of maximising the benefit. I'm going to talk a bit about a particular manufacturer of heat pump. They're not the only ones, it's just one I'm familiar with, and so I want to talk about them and what they can do for us. And then we'll get on to smart grid, and then on to e-managers, and then a bit of a summary. So if we're talking about technologies like this, we're looking at PV, possibly EV charging points, battery storage, and heat pump systems. I'm trying to put them together as an approach. So maximising benefit. Photovoltaic cells or PV will generate electricity not just when the sun is shining, as David rightly pointed out to me, but in daylight. If it's light, they're generating. The lighter it is, the more they generate, but they are generating. And therefore it's a no-brainer. They reduce your electricity bills from day one, and they pay back within 2 years, 3 years.
And more, dependent on the size of the system and the size of the battery, that may extend the payback because of the greater investment. But essentially, certainly within 5 years, you will get, if you've got a really big system, it might be 4.5 to 5 years. But we're seeing generally 2 to 3 years as the payback.
Payment. So if more electrical power is generated than is required, the excess goes to the national grid. So if you're not doing anything with it, it just disappears off down the grid, and you might be lucky and get paid for that. And if you do, you're going to get about a penny
to 5.5
to about 5.5 pence per kilowatt hour you generate. Bearing in mind that it's costing you 38 pence a kilowatt hour on domestic and 45 pence as a minimum on commercial, and a hell of a lot more if you don't have a proper, if you've fallen outside and you're on a what's called a variable rate. It gets very expensive. So trying to utilise that energy to the best is a no-brainer. So some of the simple things we can do is use more power during daylight hours. So if you're in a domestic household, run your domestic machines during the day. Your washing machine, your dishwasher, anything, your tumble dryer, anything like that. If you can run them during the day, you're reducing your costs. You can also fit things like Emerson switches or solar boost or things like that, which will take the excess PV and drop it straight into your hot water cylinder. So your hot water cylinder heats up over the day free of charge. Never mind your gas boiler or your oil boiler, it will heat it free of charge. But if you're in a commercial environment, it's a little bit more difficult, so you need to sort of think about modifying your workforce behaviour to reduce their nighttime usage and maximise, so train them to do the laundry during the day and not overnight and things like that. It's not difficult, but it takes a bit of effort.
And also look at what you're leaving on.
Yeah.
If you're in a commercial unit which isn't got tenants and residents, you shut the door and go home, the unit's still using energy, but check into what is being used and why. And if you want a good idea of what kind of usage you're getting, ask for your half-hourly data, and then you can see where there might be spikes that you've never understood, and then you can investigate them. And that way you can cut back your nighttime usage and then shift everything to when your renewable energy is being created.
Store excess electrical energy in the battery for later use. Clearly tying a battery into PV is beneficial.
Yeah, almost essential.
Store excess electrical energy as thermal energy, and I'll talk about that a bit later. And then if you think about this, for every kilowatt hour of energy you store rather than export, you're saving 37 to 44p.
As a minimum.
As a minimum. It's a no-brainer. It's easy. So domestic set household appliance to run during the day is easily achieved with time clocks. With the workforce, you need to change behaviour, but again, it's not difficult. It would be beneficial to have a simple control box to control how the electrical energy is used. And there's a guy in the room who could do that for you, Ian, who does these boxes and will be of great benefit to you if you've got a mixed system to control that. There are also companies out there with heat pumps that provide some of this support already. So this is a particular brand of heat pump. I picked this one because I know it. It's not the only one. I'm not advocating this one over any others. It's just that I happen to know this heat pump. And they do a domestic range and they do what's called a commercial range. And the commercial range, they have a unit that's 100 kilowatts and you could put 6 together, so you can do a 600 kilowatt output system on it. With the commercial range, they have software built into it that will control your PV. With domestic range, they have a box that you put on the wall with the software built into it that you can control your PV. So EcoForest, 22 kilowatts for domestic, up to 22 kilowatts for domestic, up to 600, and then smart grid enabled, and also e-manager integration. Smart grid enabled means that smart grid allows the heat pump controller to receive a ramp up or a ramp down signal. Generally that comes from the DNO supplier, and they provide this signal and say, we've got excess energy at the moment, ramp up. Or we're short of energy at the moment, ramp down. If they ramp up, you can lift the temperatures of your thermal stores in domestic hot water. If you ramp down, you can reduce them whilst maintaining minimum temperatures. You don't allow it to go too low. That smart grid is really important. If we're not using something like an EcoForest that has the box built in, most, if not all, heat pumps now have smart grid capability. And then Ian can provide us with a box that will make use of that smart grid, provide a signal to the heat pump, say run harder. We can then tell it what to elevate the temperatures to in the thermal store and make use of that energy. And we're now storing thermally rather than in batteries. So you fill your battery up first and then you go and dump it all into your thermal store. So much like smart grid, e-manager controls the thermal store temperature and DHW cylinder temperature to make best use of the PV. It will also control PV to battery storage and EV charging, and it will do gets the best control of PV generation, providing mostly cost-effective use and saving this 37 to 44p a kilowatt hour. It's not the only way of doing it, as Ian's got boxes that can do this for us and can do software. And if you're then looking at an energy centre, you can do exactly the same with an energy centre or with an ambient loop. You can have these controls. With an ambient loop, you can put these heat pumps in that does it locally. With an energy centre, you can have the control levels to do all of this. And this is typically what happens if you're looking at your standard set point. 35 degrees heating would be for an underfloor system, and we can ramp it up to 60 degrees. And you'd have mixing after the thermal store so that you control the temperature. Same with cooling. Remember, this works with cooling as well. And cooling is needed when the sun is at its strongest. So again, that's a real potential saving there on costs. And that can drop your cooling temperature from your store for cooling from 15 degrees to 7 degrees. So it's a fair amount of energy you're storing there. Same with domestic hot water. And if you're very lucky and got a swimming pool, you can do it with your swimming pool as well. Be nice swimming at 32 degrees. Summary. So this is just a tie-up. PV will provide both savings, reduced carbon production, helping towards net zero targets. It's a no-brainer. Installing a heat pump will also reduce carbon production and future-proof. Installing PV and a heat pump with an e-manager or something similar will increase the savings and further reduce carbon production, so you're getting the best of both worlds. If you've got PV and a heat pump, it's a no-brainer to do this.
Good afternoon, everyone. So my name's Adam. I'm one of the directors at Signature Tax. I'm going to be here for the next 5 to 10 minutes, just going to go through a high level of what we do, who we are, and what we can offer to the room. So we're basically a top 60 national-based accountancy and tax practice. Today we're going to focus on tax. So we're going to focus on tax, our offerings, our services, the model that we offer, and then we'll go through a few kind of scenarios of our services, because our services are quite long in what we offer. So we're a 45-year-old business, kind of born and bred in Blackburn in Lancashire. Over the last 10 years, we've had some fantastic growth. Our model changed. We were provisionally in a small accountancy practice, operating out of Yorkshire and Lancashire, looking after local people, local businesses. Over the last 10 years, we've grown into a corporate entity. We're now made up of multiple divisions, which I'll run through on a kind of really quick high level. So our accountancy division is split into multiple departments. How that works is, so we've got our SB unit, which is our small business unit, to kind of staying true to our roots. We kind of don't want to forget where we came from 45 years ago. We don't want to forget the clients that we kind of took us to where we are today. In that business, then we've got the small business unit. We've got management accountants that looks after kind of large to small, kind of medium-sized businesses. We've got AMS Accountants Corporate, which is our corporate entity, including kind of corporate accounts, audit, regulated, non-regulated FCA audits. We've got a separate medical business in there, which is not really relevant, but that just looks after anybody within the healthcare industry because they have a specialist need: doctors, GPs, locums, pharmacists. And then we have, and care homes. We do a lot of care homes. I think we look after about 350 care homes across the UK at the moment. On the accountancy side, on the tax side, it's a little bit more. So that's the accountancy group. And then Signature Tax is a boutique tax business that looks after all tax services for our own clients. But I'd say probably that's relevant to probably about 30% of our client book. Most of our clients are other accountancy practices clients, but we just manage the tax work because it's a specialist requirement. Most of our guys are chartered tax advisors and have worked in that kind of top 4, top 5 industry for tax. So just going to kind of quickly go through some of the services that we offer, and I'll just pick out the more relevant ones. So capital allowances, as some of you may be aware, easiest way to explain it, doesn't work for residential buildings, corporate buildings. If you take off the roof, give it a shake, everything will fall out. Your bricks, mortar, your electric, your plumbing, anything left, we can claim tax allowances for. Depending on industry and sector, it can range from anything between 8 and 25% on the purchase price. After 2014, there's mandatory pooling. So anything brought pre-2014, the claims are a lot easier. Anything kind of new to purchase, we'd get involved pre-purchase stage to make sure the legals and the contracts are in place, and then the capital allowances can be claimed. Land remediation relief, as some of you might be aware, as the guys were talking about, is kind of contaminated land, whether it's asbestos, dilapidated buildings, chemicals. The cost of remediating the land is quite high, but HMRC have got an allowance in there to bring the cost down, which works out between 19 and 10%. I'll touch on patent box slightly, not massively relevant, but it could be. It's if you hold any patents that are integral feature to your business or to the product that you sell, we can bring down your corporation tax to 10%. So actually I got this one from Dan. The Dyson example is a great one. So Dyson example, 80% of their sales is the Dyson Hoover, 20% is in accessories. The patent that they took was a slimline patent on the hose that they click in rather than the cyclone technology, which enables them to pay 10% on 80% of their profits, the remainder 20% on the accessories where they don't hold any patents. They'd pay the full corporation tax at 19% or 25% from later this year actually. Research and development tax credits, most of you are probably aware, it's been a big thing, it's been all over the news for the good and the bad and the ugly. For us, we're a regulated firm. It's one of the only tax elements that's not regulated, so there are a lot of rogue players in the market. For us, it's very simple. We've got a very good team of kind of engineers, chemical engineers, biotechnical engineers that build the reports. We build a good, robust report. We've got a good HMRC team that work with HMRC to make sure that they go through. I think the kind of next bit that'll probably be relevant to pick up on this is probably the structures in the corporate finance world, and then I can touch on actual finance. So one of our divisions works on corporate finance, M&A and restructuring. Now, how that kind of works from a tax perspective is just looking at your businesses and making sure we're structured in the right tax manner, because making sure the IP is held in the right entity, making sure our assets are held in the right entity. It's risk analysis to say, well, actually, where do the risks lie within our business? Are we holding too many assets and too much trademark and too many patents within one trading entity? How do we make it efficient? How do we make it safe for tax? And how do we protect the business over a longer period? The next bit, I'm going to kind of jump right to the end, because the more relevant bit is on the finance element. So over the last kind of probably 12 months, looking at the change in the market, we've got in our corporate finance division, we've got 2 separate divisions. So we've got corporate finance, which works on anything with kind of 15 million to 200 million, working at kind of in bank rates, purely based on asset property finance, always kind of on that market. Now what we've done is we've kind of partnered with a firm called Western Financial more recently to look at the lower market, especially energy, that we're working with Dan and the team on. Now how it works with Western Financial is there's 2 models. You've got the power purchase agreement model, which has been around for quite a while, that everybody's aware of. The next piece works along kind of asset finance and carbon emissions to say, well, actually, we look at the business plan, we look at where you currently are, what the financial input will be, where do we drop to, what do the savings look like, based on that, irrelevant of where the books are. So we did a loan recently, for example, for a company that's got a negative £10 million in the book because they're not in the mode of sales yet. They're in development stage. So a company that does pure R&D, the directors are putting about £10.6 million. They're making a massive loss. But based on the fact that the losses, it's the director's own money, based on the savings, based on contracts that they've got in place with certain building societies that are already in place, we got them a loan of 3.5 million to make their building more efficient. And it was kind of, I think they were spending the money, it's not gone through yet, they were spending the money on kind of PV panels across the roof to lower their manufacturing costs, which they're starting to manufacture in the next couple of months. So initial savings will be quite big compared to what their production costs were, and what that lowers their item costs from manufacturing as well. So if anybody does have any questions on finance, you know, you'll find me around for the next hour or so, I guess, and I can help where we can. And if you've got clients, for example, that are looking to use your services, but they've got the kind of, and the capex costs are too high, they need support because then over the long term the savings are, we can work the calculation to say, well, this is the capex cost, this is the cost of our savings, what do our payments look like, and what period do we get over? Because the rates are generally, I don't think they're too bad depending on the business model. You can range from anything kind of to 1.6 to 8%. It's quite a wide range above base rate. I think that's my piece done. Zach, over to you to touch base on. Go on,
Zach's strategy thing. The first place any business must look at is their tax positions. What taxes aren't they claiming that they're eligible for? Because this could be money that they're entitled to. And if they're not, that could form a big chunk of the initial outlay. So if you've looked at a tax up there that you're thinking, well, my tax advisors haven't spoken to me about it, have a chat with Adam and Zach, find out what your tax position is and whether you're actually owed anything, because otherwise that's money gone to waste and money that could be put towards the solution that Richard and David have come up with. Once you've done that, then it's looking at the finance options.
Agreed. I think the one bit I actually didn't mention was the CCL. So most of you are aware of what the CCL is. Not many people are aware that you can reclaim the cost of your CCL going back 5 accounting periods based on what you do over the next 12 months to make yourself as green and as zero carbon as possible. And we can help with that and building the reports and making sure we can claim back. And that can, again, it only works in certain manufacturing companies, but that can end up to a substantial amount. I think we've just got one in that we did the other week. Savings for the company per year was about £227,000, and given the current cost of energy, it gives a lot of businesses breathing space to reevaluate their businesses, get restructured, and carry on the growth plan, rather than looking at it and say, well, actually, you know, we're a 5 million profit business, we're now 1 million because the cost of electricity has gone up to X amount. It gives them breathing space to reevaluate, purchase, and grow their business from there.